Hello everyone, I Shalini from CSE department welcome you all to St. Andrews Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrews Institute of Technology and Management is the best college in entire northern India. We deliver best possible education in the region and also in the country. We have various courses running into our colleges from BTech, BBA, BCA, and we are starting with MBA Law and Architecture in the near future. St. Andrews Institute of Technology and Management is the best college that you will be admitting your child to. We provide the best education and the best placement in the industry. The subject I am looking forward to is Principles of Software Engineering. The code is CSE 302F. This is a CSE 6 semester subject and this is MDU affiliated college. The topic is Software Lifecycle Model. This is lecture number 3 from unit 1. Now, in previous lecture, that is lecture number 2, we already studied the basic of life cycle models and we carried the very first model, that was the waterfall model. So I would request before going to this video, you just read the previous video from lecture number 2 of unit 1, which is very essential. So this is a prerequisite of this video. We have discussed waterfall model, which was in linear sequential model. Now we come to iterative model. What is an iterative model? See, if I look at this word iterative, what information does this provide me? Iteration means that I am kind of repeatedly doing something. I am repeatedly doing some task. So here, what is the task that I am doing in software engineering? I am producing a software, and these softwares are being produced iteratively in a repeated manner. Iterative model can actually be a linear sequential model also, and it can be an evolutionary model also. If the software that is produced in being any of the iterations, if I throw it and just gain the requirement from it and go to the next, then it will become a linear sequential. Wherein if I do the changes to the previous versions, then it becomes evolutionary model, right? So this has to be very clear into your mind, because questions come indirectly also. Okay, so now in the iterative model, iterative process starts with a simple implementation of a small set of software requirements, which iteratively enhancing the evolving versions until we develop the complete software and it is ready to be deployed. In this model, you can start with some of the software specifications, a few. You can take few requirements and you can start, which was not the case in waterfall model. In waterfall model, what we used to do, we need to have each and every requirement before going to the next phase, and it was a very confined thing for us. But in here, we can start with few of the specification, we can develop the first version, and then if this first version need any change, then again we go to the next version with the help of new iteration. So each release of the iterative model finishes in an exact and fixed period of time, that is called an iteration. An iterative lifecycle model, it does not attempt to start with the full specification of the requirement, which is the biggest advantage of it. You can start with few requirement, right? Instead, the development begins by specifying and implementing just part of the software, just a small part of it, which is then reviewed, and again we identify further requirements, and again we add and make it better. So this process is repeated, producing a new version of the software at each iteration of the model, right? And when we will finish with each of the iterations, when we are satisfied that no, this is my final project and now I am done. Unless and until we are not satisfied, we will continue with the iterations. Okay. See, in this figure also, what is given in the first iteration, we have requirement, then we analyze this requirement, and then we design a DFD or a UML kind of cases, or any sort of design of the system is being done. After then we do the testing and implementation, and we again review it. Then again in the second iteration, we design, test, implement and review. Again into the third, we do the same thing. So iteration 1, iteration 2, iteration 3 gives me 3 different versions of the software. Now this iteration number 1, see, now I'll tell you the difference between a linear and an evolutionary model, right? See, if you take this iteration number 1 and you actually throw it, if it is of no use, you take iteration number 2 and then throw it, and you keep only iteration number 3, then it becomes a linear sequential model. Why? Because the previous model, what they are doing is they are not keeping the 2 previous iterations. What they are doing is that they're just doing it for the requirement, to just to get the requirements correct, and then keeping the third. Wherein in case of evolutionary model, I'll take the first iteration also, the second one also, and the third one also. So what I'll do, I'll see to it that my first iteration, my second iteration, my third iteration is actually each and it's just like the evolution in earth, I would say, in mother nature, how it goes like. In nature also, how it goes like, first humans came, then they evolved, then again a new species kind of developed, then again evolved, then a new species come up. So this is evolution, with change is going into the same, right? So we understand the difference between the two. Iterative, if I ask for linear sequential model, like define linear sequential model, you can take the example of waterfall model we discussed previously. Iterative model, wherein a prototype is being produced and the prototype is thrown. Wherein if I ask you what is evolutionary model, then I'll take iterative model, wherein all the versions of the software are being kept, and the next model that we will be discussing in the next coming up slides. Okay. So what are the phases of iterative model? The very first phase is requirement gathering and analysis. What happens in this phase? In this phase, requirements are gathered from customer, they are checked by the analyst or the senior member team, whoever is in contact with the customer. He will be the one who will have one-to-one interaction with the customer. He will be the one who will be noting down each and every single requirement from him. So, and he will see, then he will tell the analyst that you check if we can fulfill this or not, and then the analyst check, and he tells that this will be the budget, this will be the cost, this will be further needed, or if it is feasible, and if it is not also, then for everything he'll say it, okay, this is feasible, I can do it, or we can do it. This is not feasible, we cannot do it. He will also tell that this will be the time duration in which it will be completed, this is the manpower. So then again the senior management will go to the customer and tell him that this will be the budget and this will be the time. Okay. After this is being done, we go to the next phase, that is the design phase. In the design phase, the team design the software by the different diagrams, like the data flow diagrams, activity diagrams, class diagrams, state diagrams, UML, etc. Implementation. In the implementation phase, the requirements are written in the coding language, and this is the longest phase. Why the longest? Because you are actually coding the software. The programmers, they are sitting down and they're transforming this set of instructions, these programs, into software. Next is the testing phase. After completing the testing phase, software testing starts using different test methods. There are many test methods, but the most common are white box, black box, gray box, unit testing, integration testing, testing the entire component testing, testing the entire system. So testing has to be very, very rigorous, I would say. Why rigorous? Because you should not be satisfied. A tester should never be satisfied, because if he is satisfied, then no development can take further. The developer or the coder, he likes his code to the best. From his point of view, there is nothing wrong with it. So it is the tester's responsibility to actually find fault with the systems. Okay. Next is the deployment phase. So after completing all the phases, software is deployed to its environment. It is actually put into the environment that the customer needs. Next is the review phase. In this phase, after the product deployment, review phase is performed to check the behavior and validity of the developed product. Now, what is the validity? How it is behaving? So, it will take reviews based on that. And if there are any error found, then the process again starts from the requirement gathering phase for the second iteration, right? Maintenance. In the maintenance phase, after deployment of the software in the working environment, there may be some bugs, some errors, or new updates which may be required. So, maintenance involves debugging and new addition options. So, we complete with all the phases of iterative model. Okay, applications of iterative model. See where iterative models can be classified, or which are the areas like we can take this model and develop our software. This is an incremental development, right? So there are various scenarios that it would be put into. The first is the requirement of the complete system. So where in the requirement of the complete system are defined and understood, we can put iterative model. Major requirement must be defined. Why? Because you need to know the major requirement. Okay, you can go, you know something, you don't know something. Few requirements can be entertained at a later stage, but the major requirements, see, I'm going ahead and developing a website. So the first requirement is for whom? What kind of customer? Is it an e-commerce website, or it is a just education website, or just an entertainment website? So there's major requirements which have to be defined. Okay, there is a time to the market constraint, right? A new technology is being used and is being learnt by the development team while working on the project. So you always get the latest into the market, right? Resources with needed skill sets are not available and are planned to be used on contract basis for specific iterations, which also further reduces your cost. There are some high risk features and goals which may change in the future. So this is the biggest application. See, if any risk occurs, or if anything that has to be accommodated, so the system need to be adaptable, so that it can accommodate the changes, the changing requirement. So this is the area where it can be put to use, and this is one of the advantages also. So next we all discuss the advantages. Testing and debugging during smaller iterations is easy, right? During smaller iteration, testing becomes very easy because it will not take large time, and you will get a refined product. A parallel development can be planned in iteration model. This is very very important thing. Like you, say for an example, this new mobile phones are coming with an Android version. Then the Android version, it will release looking at the market. Then it can also take this feedback from this iteration and can go ahead and produce the next version. Say it is version anything, say if for any software it is version 1, then I can put some my updates or anything, and then I can say the next version is version 1.1, the next can be 1.2, 1.3, right? So this is the biggest advantage of it. It is easily acceptable to ever changing needs of the project. This is the beauty of this model. You change the change has to be accommodated, and anything which can accommodate the change, any model which does it is very very nice. Next is risk are identified and resolved during iteration. This is very nice. you know in the waterfall model, we could not resolve any sort of issue. Once it goes to the next phase, the it cannot feedback or it cannot loop back. So this was one of the major disadvantages of waterfall model that this model actually took into account. There's limited time spent on documentation and extra time on designing. So this is also important. Disadvantages, or what are the cons of iterative model? Anything that has so much of advantages can also have loopholes also into its system. And what is a loophole? It is not suitable for smaller projects. Like, why do you waste each kind of iteration into smaller project? You can actually look forward to larger projects. For smaller project, we definitely had waterfall model. More resources may be required, which is very true, because you are, every time you are doing an iteration, you are releasing it, you are developing the next version. So what you're doing is that you actually see the same manpower which actually was designing once into a waterfall model is actually now what it is doing, it is now again doing the next iteration, third iteration, fourth iteration. So many resources are required, the cost resources, the cost effort, the time effort, different things. Design can be changed again and again because of imperfect requirement, which is very true. So again now you have to get it designed again, get the designer to design the next system. Requirement changes can cause over budget. This is like we have been discussing from starting, that you are constantly changing it, so it will have a budget issue. Project completion date not confirmed because of the changing requirement, because there was ambiguity in the requirement. The ambiguous requirement could not actually make you kind of aware beforehand that how much time will be needed, right? Because the requirements were vague, they were ambiguous. You started with a few requirements. Remember, in the first slide we saw the few specifications, few requirements, where in waterfall model it was very precise time that you could be guessed as to how much time it will need or how much it will be required for the completion of the project. Next we come to the spiral model. The spiral model, it combines the idea of iterative development with the systematic controlled aspects of waterfall model. This spiral model is a combination of the two, iterative model and waterfall model. The iterative development process model with linear sequential development model, that is a waterfall model with a very high emphasis on risk. So this risk evaluation is one of the focus in the spiral model. It allows incremental releases of the product or incremental refinement through each iteration around the spiral. So it is happening around the spiral. The spiral model is one of the most important software development lifecycle models, which provides support for risk handling. So any kind of the system, actually it is very true also in our daily sense. We really like things which can actually take risk. If any system, we put our cost also, we put our effort also, we buy something, and the system is not prepared to handle the risk, then it is such a, I would say, fatigue, for becomes such trouble for the customer. So risk handling has to be accommodated, and spiral model looks into this. So it's a very positive aspect of the spiral model. The exact number of loops of the spiral is unknown and can vary from project to project. Each loop of the spiral is called a phase of the software development process, which is very true. So one loop means one phase of the software development process. The spiral model is also called meta model because it subsumes all the other SDLC models. Spiral model is the one that is actually, I would say, superseding, or kind of it accommodates the best of all of them, and along with the risk handling capacity, right? So it is a meta model and it's an evolutionary model. Evolutionary, why? Because we are doing evolution into the software. So the software is getting evolved with each spiral around that moves around it. So with each spiral going around, the software is actually improving itself. See, this is how we can see for the diagrams. There are 4 quadrants that image is being divided into, and there's a spiral green line that is going on. So what we can see is the 4 quadrant, the very first quadrant. What is it? Objectives, determination, and identify alternative solutions. So what you're doing, you're determining the objective and look for alternative solutions also. right? The second is identify and resolve risk. You see, and you see what are the risks that are there, you identify them and you try to resolve them. Then you develop the next version of the product, right? You are going with the next development, like this will be my next version based on the risk that came. And then you review and plan for the next phase. Okay, you know the radius of this spiral at any point of time. See, anytime if I go from, if I start going radially on the axis, then this radius will give me the cost of the project. That up till this phase, this is the amount of expenses that I've spent on my project. Okay, now angular dimension. Angular dimension represents the progress made so far in the current phase. So angular dimension will tell you as to what is the amount of process, like what is the current phase that the system is into. So each phase of the spiral model, it is divided into 4 quadrants, right? Identifying this, sorry, objective determination, identifying alternative solution. You know, the very first it will start with objective determination. Then you will make a kind of develop a prototype. Then you'll identify the risk. Then you go to the next. You'll see how you'll review this risk. You'll improve your prototype or you'll improve your software and you'll try to incorporate this risk, and then again review and plan, and then again identify alternative solutions. You'll see that what are the alternative solutions that can be accommodated, right? Okay, now we come to the functions of these 4 quadrants. The first is objectives determination and identify alternative solutions. Requirements are gathered from the customers and the objectives are identified. What we do, we gather all the kind of requirements, we sit with the customer, we do one to one, we do over there and we ask him, we show him different scenarios. So all the possible requirements that we probe him also, we can gather from the customer, we gather it, and objectives are identified. Elaborate and analyze at the start of every phase. Then alternative solution possible for the phase are proposed in this quadrant, and we'll look at what are the alternative solution that can be possible. Uh, Next is identify and resolve risk. During the second quadrant, all the possible solutions are evaluated to select the best possible solution. Then the risk associated with that solution is identified, right? So you see all the solutions and you try to select the best out of them. So all the solutions that you have proposed, you select the best of them, and you see that what are the risks that this solution can have, or this, I would say, whatever that we are planning, the path we are trying to follow. So what will that risk this solution will contain, right? And how would we will be resolving these risks using the best possible strategy. So at the end of this quadrant, prototype is built for the best possible solution. Because this best possible, why we say, because at that point of time that was the best possible solution that we could imagine as from a developer point of sight. And then if we up till this level, if we I need to have this requirement previously get the, then I would have taken it into previous account also, not that requirement. So up till here my prototype is said to be the best possible solution up till the information that I am having, depending upon that. Next is develop next version of the product. During the third quadrant, the identify features are developed and verified through testing. Now what you do, you identify the features, okay, and you develop and verify them through testing. At the end of third quadrant, the next version of the software is available. So we are ready with the next version, which is an improved version of the previous one, right? Okay, now the fourth one, that is review and plan for the next phase. In the fourth quadrant, the customers evaluate the so far developed version of the software, and in the end, plan for the next phase is started, right? So this is continuously evolving itself, continuous evolutionary. So it's the best example of evolutionary model. If I ask you Like explain evolutionary model, explain meta model, explain spiral model. The answer is the same for all the three. So now you know as to what exactly you're supposed to write into this. Examiner may trick you. He may trick you into asking from all corners, like explain this, explain that, explain this, explain that. He will try to kind of confuse you, but you have to be very very clear, okay? And this clarity will only come when you understand the topic very well. Okay, so now we come to the advantages of the spiral model. The first advantage is risk handling. The projects with many unknown risks that occur as the development proceed. In that case, spiral model is the best model to follow due to risk analysis and risk handling at every phase. So each phase is actually the one which can accommodate risk. So this is the best model in case of risk handling. Next we come to good for large product. It is recommended to use spiral model in large and complex product. Next is complexity in requirement. Changes request in the requirement at later phases can be incorporated accurately by using this model. So this is a very very flexible model. I'll say the most flexible model is the spiral model. So the name is came from spiral. So the name itself suggests that it has large amount of flexibility in itself. Right? Next we come to customer satisfaction. Customer can see the development of the product at any phase. The customer can say, today I want to know what is the development of my software. So this is very very transparent into the system that you can actually show him. So this is everything is clear to him. So thus they are habituated with the system by using it before completion of the total product. So this is very very customer satisfiable product. So it is risk handling capacity is nice. It is very good for large products. It is flexibility in the requirements can be accommodating, and is the best possible model to satisfy the customer. Okay. Now we come to the disadvantages of the spiral model. People write it as disadvantages and so do, like you have to explain it in the books, but I don't agree to this word disadvantages. I would say what are the cost of it, because good things comes at a price. So this is kind of say, and good things are expensive also. So this is the very first and second disadvantage, or I would say the cost of the spiral model. It is complex. The spiral model is much more complex than other SDLC models, right? Because spiral model complexity is very very high. Why? Because it has tried to incorporate it from all the different software models. What it has done is that it has taken the best of all the models, and what it has done is that is actually giving you the best product, best possible solutions. Anything that can withstand risk is actually a durable thing, na? So spiral model is durable, so the complexity increased in the designing. In each and every phase the complexity is actually increased. Expensive. As I said that good things are expensive, so spiral model is actually expensive, and it is not suitable for small product. The third point is too much dependable on risk analysis. The successful completion of the project is very much dependent on risk analysis. Without very high experienced expertise, it is going to be a failure to develop a project using this model. Why? Because it is needed for large models. The costs are large, the complexities are. So you need you need experts to actually develop any software with the help of spiral model. Difficulty in time management. See, as the number of phases is unknown at the start of the project, so time estimation is very difficult. And this has to be like, we agree also to this point that we don't know what kind of risk come into the system. And risk are actually unknown changes. You don't know them beforehand. They come at once and they has to be catered at once. So time management will always be an issue into spiral models. Okay.
Now we come to the important questions. The important questions are here. Explain iterative model, briefly describe spiral model, what is meta model, write a detailed explanation of it, what are the evolutionary model, describe in detail. So the examiner, he may ask you, try to confuse you, but you have to be very, I would say very apt as to answering him, to know that what he is answering, what he is questioning, sorry. So you need to have an answer planned out, and this only comes when you have a detailed knowledge of the thing that you have studied well. If you study well, he may ask you from any angle and you'll be able to tell him. So I ask you, please study this well, and all the best. Take care of yourselves. Bye. Thank you.